In our next chapter, we're going to focus on radical expressions and radical equations, but we have to kind of build a foundation to understand that. So for this first section of the chapter, we're going to talk about finding roots, and that's going to help us build our foundation for radical expressions, okay? So very first thing, we're going to talk about square roots, okay? So we do need a couple of definitions to kind of set the stage, then we'll start talking about our square roots, and then potentially cubed roots, and then potentially higher roots, which we would call nth roots, okay? So first, we have the definition of exponential notation. Now, we've dealt with exponential notation, but we want to just remind ourselves of the formal definition. So an expression of the form a to the n, where a is the base and n is the exponent, indicating how many times the base is used as a factor, is called exponential notation, okay? So we basically have a times itself n times. So a is the base, it's being multiplied as a factor repeatedly. N tells us how many times to multiply a. Now, there are two exponents that come up so often they kind of get their own name. So we would say a number squared is that number multiplied by itself twice. You could say a to the second power, you could say a to the power of 2, or you could just say a squared. And I do bring this up because in a minute we're going to talk about square roots. And that word square kind of means something, okay? Now, we could also say a number cubed is that number multiplied by itself 3 times. We could say a to the third power. We could say a to the power of 3. We could also just say a cubed. And again, I bring this up because in a moment we're going to talk about cube roots. Okay? So just kind of keep all of that in mind. First up is topic 1, which again is just square roots. So I'm going to talk about square roots kind of informally, like how we just know them in practice. Then we're going to talk about this like super formal definition of a square root, and we'll get some practice there. So first of all, we have some more definitions that you need to know. First is the reverse operation of squaring a number is finding the square root of that number. So in math, we have inverse operations. So like the inverse of adding is subtracting. Adding and subtracting undo each other. The inverse of multiplying is dividing. Multiplication and division undo each other. The inverse of taking a number and raising it to the power of 2 is finding its square root. Okay, so they're just inverse operations of one another. Okay, and then we have the square root of a number. Now, this is a very informal definition, but it helps you understand what's really going on. So pay attention to this one. Just know it's not super fancy. So the square root of a number is one of 2 identical factors of that number. So I could say, okay, the square root of 4 has to be 2. Well, how do I know that? I know that because 2 times 2, or 2 squared, is 4. So if I take a number and square it, then the square root of that number is the number I initially squared. Okay, so that's kind of what we mean by these inverse operations. So squaring a number and finding its square root, they just undo each other. And again, the square root of a number is one of 2 identical factors of that number. Okay, again, that's not a formal definition, but it helps you kind of understand what's really going on. Now, this symbol right here, this is called the radical symbol. You need to stray away from calling it a square root symbol. In some instances, it is a square root when we're undoing squaring a number, but there are other instances where it needs to be a cube root or a fourth root or a fifth root or just generically an nth root. So again, just kind of get away from calling it specifically a square root unless you're quite literally undoing squaring a number, okay? And then the stuff that we put under the radical, we call that the argument, but here, very generically, we would say the stuff that we put under the radical symbol is called the radicand, okay? Now, let's talk about the formal definition of a square root. So the principal square root, and principal is kind of important. So the principal square root, it says if a is a non-negative real number, the non-negative number b such that b squared equals a, denoted by b equals the square root of a, is the principal square root of a. Whoa, okay? It seems like there's a lot of a's and b's and a lot of words, okay? So first we just need to know a and b are non-negative. That means they can be 0, they can be positive, they just can't be negative. Okay, so what we have here is we know we have some number b such that if I square b, I get a. So this would be the 2 identical factors of a. So we already know the square root of a number is one of 2 identical factors of a. So if b squared ends up being the 2 identical factors of a, then b by itself is the square root of a. We just have to denote and make note that they're both non-negative. So b equals the square root of a is the principal square root of a. Just know that that means b squared equals a. So this is really the same thing as up here. It's just much more formal. It's very fancy, okay? So just know nothing has changed. The hard and soul of this definition is exactly the same as what we talked about informally. It's just kind of fancier, okay? So when we talk about a principal square root of a and b would be non-negative. Now, let's evaluate each expression here. So that's example 1. So remember, we're finding square roots, and we're going to talk a little bit more about what that means kind of later when we see the bigger picture. But for now, we're just looking for one of two identical factors of each number. So example 1 just says evaluate each expression. In part A, we have the square root of 121. Now, we're looking for two numbers that are identical that when we multiply them, we get 121. Well, that would happen to be 11. If I take 11 times 11, that's 11 squared, that equals 121. That's one that you technically should know. You should probably know your first 15 or 20 perfect squares. If not, you definitely need a calculator. But we can say that the square root of 121 is 11 because 11 squared equals 121. So in this case, A is like our 121, B is like our 11. So if we go back to this principal square root definition, we have if 121 is a non-negative real number, which it is, then the non-negative number 11, such that 11 squared is 121, denoted by 11 equals the square root of 121 is the principal square root of 121. So you can easily fill in these numbers for A and B, and then that definition kind of makes sense. It's still wordy, still a lot going on, but it makes sense. Now, as far as your calculator is concerned, just in case you don't know how to find a square root, let's take a look. I think it's this one. Yes. Okay. So if you need to find a square root, if you have a graphing calculator like this, like the TI-84, this first column of buttons is where all of the action is going to be at. If you look about halfway down that column, you have a button that has x squared on it. That's its main feature. It'll square something. But if you look in the corner, it has a blue radical symbol. That tells you that's its hidden second feature. So to get to that radical, I want to hit the blue second button. Then I want to hit the x squared button. It pops a radical on my screen, and all I have to do is type in the radicand. Now, this is specifically for a square root. So I want to type in 121, and bam, it pops out the 11. And that should make sense because 11 times 11 is 121, okay? So that's how you'd use your calculator if you need to. Let's look at the other examples. Okay, so for part B, we have negative square root of 36. This is really the same as saying negative 1 times the square root of 36. So order of operations tells me that I would take care of my square root first. So what is the square root of 36? What are two numbers that are identical that when I multiply them, I get 36? Well, 6 and 6. So the square root of 36 is 6. But remember, we have to multiply that by negative 1. So my final answer is negative 6. So if there is a negative outside of the radical, like in front of the radical, that tells me that the answer is going to be negative. Okay? Now, let's talk about C. So part C is maybe a little weird. We do have this fraction, but the cool thing is there's this rule that we're going to learn much more officially down the road, but just take me on faith now. If I have a radical with a fraction under the radical, I can split the fraction into two pieces. I can basically apply the radical to each part of the fraction. So I can find the square root of 1 and the square root of 16 separately. Now the square root of 1 is just 1. So 1 times 1, or 1 squared is 1, so the square root of 1 is 1. That's kind of a mouthful, but we know the square root of 1 is just 1. And then the square root of 16 is 4 because 4 times 4 is 16. So this simplifies to just 1/4. Okay? Now for parts D and E, we have to be careful. They look very similar, except in part D, all of the numbers are squished under one radical. Part E, we have two separate radicals. And one thing that you hopefully can kind of remember about the order of operations is with the order of operations, think PEMDAS. So we have please, excuse, my dear, Aunt Sally, or just PEMDAS. The P stands for parentheses, or any type of grouping symbols. Sometimes you can include a square root there. Sometimes the stuff under the radical needs to be dealt with first. So in this case, part D, the radical is kind of like a set of grouping symbols. So we need to add first, okay? So when we add here, we get 9 plus 16, which if you need a calculator, grab your calculator, but 9 plus 16 is 25. And then we want the square root of 25. Well, we want one of two identical factors of 25. So if I take 5 and multiply them, they're identical. They give me 25. So that tells me the principal square root of 25 is just 5. Okay, so in part D, we add first, do the square root second. Part E is totally different. So part E, we have to follow the order of operations again, okay? But in this case, we have to do the exponent first, the addition separate, okay? So sometimes we'll put exponents and square roots together. Sometimes we'll put parentheses and grouping symbols together. In this case, we're going to put the square root kind of the exponents. We want to do the exponents first, the addition second. So we want the square or the exponent. We want to do the square roots first, addition second. So the square root of 9 is one of two identical factors of 9. So what number, when multiplied by itself, gives you 9? Well, 3. And then for 16, we want the square root of 16. What number, when multiplied by itself, gives you 16? 4. So we do the square roots first, then we do the addition. So even though parts D and E look very similar, they're quite different, okay? So you're going to get completely different answers for part D and then part E. And then finally, we have to really test ourselves. Do we understand the definition of a principal square root? And one thing that's really important in our definition of principal square root is this word non-negative, okay? The principal square root says that if A is a non-negative number, then there exists some non-negative number B, such that if I square it, I get A, okay? So we can't have this. This can't happen. Because negative 144 is not non-negative, but let's really think about that. When we multiply two numbers, we have to have two positive numbers or two negative numbers to get a positive. Or to get a negative, we have to have one positive, one negative. So in order to get a negative product, one factor is positive and one factor is negative. There's no way to get two identical factors of a negative number. And the square root of a negative number is one of two identical factors. We're never going to have two numbers that are identical to each other, same number, same sign, that'll ever give us a negative product, not in the real number system anyway. So when you have a square root, if the radicand is negative at this point, we just have to say not a real number. Okay, so that's kind of a big deal. At this point, we can't have a negative under the radical if we're dealing with a square root. Okay, so there you have it. That's the basics of a square root. I would say really understand that informal definition of the square root because that helps you understand what's going on. We're looking for one of two identical factors of a number, but then you really also need to understand the principal square root, and the key behind that is non-negative. Okay, we've looked at several examples here on how to simplify, so make sure you get some practice and understand your square roots.